Okay. In Chapter 9, we'll get into conic sections and graphing. Okay, so we are going to be graphing a lot more. But first, I do just want to kind of refresh you on midpoint and distance. Okay, and I know you've all seen midpoint and distance before because I taught it in geometry, and you learned it in geometry. I had you in geometry. Well, we're going to go over it again.
I hate to tell you.
So, alright, I'm still going to reteach how to do it, so you just got to pay attention and you'll figure it out. So, recall that point M is the midpoint of segment PQ if M is between P and Q and PM is equal to PQ. Okay, so if I have a segment
You coming to my grad party?
PQ.
I think you graduated.
Hey, come on, guys.
If I have a segment PQ, M is between P and Q, and PM is equal to MQ. Okay, so those two smaller segments would be equal to each other. Okay, that's considered your midpoint. Okay, there is a formula for the coordinates of the midpoint of a segment in terms of coordinates and endpoints. So your formula is right here. Okay, to find that midpoint M, you'll take x sub 1 plus x sub 2, divide that by 2. Take y sub 1 plus y sub 2 and divide that by 2. So you're just taking the average of your x's, average of your y's, midpoint. Okay, so if I look at the picture here, I have point P and point Q. Point P has x sub 1 and y sub 1. Point Q has x sub 2 and y sub 2. You take that x sub 1, that goes here. X sub 2 goes here. So you're taking the x's from both points, dividing by 2. Same thing with the y's. Take the y from both points, add them together, divide by 2, you'll get the midpoint. Okay, so we'll do an example of this. So we want to find the coordinates of the midpoint of segment AB, where we have A is equal to 5, 12, and point B is at -4, 8. Okay, so I usually label my points. So I have x sub 1 and y sub 1. And I have x sub 2 and y sub 2. Okay, then I can just use the formula here and plug those in. Okay, so I have x sub 1 first, that's 5. And x sub 2 is -4. That's divided by 2. I'm going to add in this comma because it is a coordinate point. Then I have y sub 1 is 12 plus y sub 2 is 8. Both of those are divided by 2. Okay, so now I can just add 5 and -4 together. That's 1 over 2. And then 12 and 8 would be 20. Yep. So I can write this as 1/2 10. Or if you like decimals a little bit better, you can say it's 0.5 10. Okay. So either of those answers would be correct. So you're just plugging those numbers into that formula. Average your x's, average your y's. Okay, next I want to move on to distance. Okay, so the distance between 2 points A and B on a number line is the absolute value of A minus B, or the absolute value of B minus A. We're not going to use the number line, we're actually going to use coordinate points instead. So you can use this fact and the Pythagorean theorem to derive a formula for the distance between 2 points on a coordinate plane. Okay, Pythagorean theorem is a squared plus b squared equals c squared. Okay, it's on that big orange poster up in the left-hand corner there. That's your Pythagorean theorem. So we're going to use that. Okay, again, just to label, this is the Pythagorean theorem. Okay, that has to do with right triangles. Yes. Okay, so your C value of that Pythagorean theorem is your hypotenuse. Okay? So I'm just going to label this right triangle here. I have this side and I have this side. Okay, your A and B values are your legs of your right triangle. Okay, those can be interchanged. So I'm just going to label this side as A and this side as B. Okay, and what we're doing is trying to find the distance between these 2 points using that Pythagorean theorem. Okay, so if I go from this point here to this point here, that's x sub 2 minus x sub 1, and then this length would be y sub 2 minus y sub 1. So we'll plug in that quantity, x sub 2 minus x sub 1 for A. Okay, that'll be squared, plus the quantity of y sub 2 minus y sub 1, again squared since that was my B value. Okay, that's equal to my hypotenuse squared. So instead of labeling this C, I'm going to label it D. Okay, so now if I wanted to find that distance, that would be this length. So I would want D by itself. So to do that, you would take the square root of both sides. Okay, so you'd have your distance is equal to the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. That's how you derive that distance formula. Okay, so this is the formula we are going to use. You won't have to repeat what we just did with the Pythagorean theorem. You're just going to use that distance formula. So I just wanted to show you how that formula is derived. This is the formula for distance. Okay, so if you flip over to the back, okay, you can see this is that formula we just derived, okay, from that Pythagorean theorem. So again, this is the formula that we want to use. Now you'll be given 2 points to find the distance between on your coordinate plane. So one point will be labeled x sub 1, y sub 1. The other point will be labeled x sub 2, y sub 2. Okay, and then you can again just plug those numbers into that formula just like we did with the midpoint. Okay, so if I look at example 2, okay, Sharon hits a golf ball 12 feet above the hole and 3 feet to the left. Her first putt traveled 2 feet above the cup and 1 foot to the right. We want to see how far the ball traveled on her first putt. So if I have, since she's putting, I'm going to draw a picture here. Okay, so she hits the golf ball 12 feet above the hole. So if we look 12 feet up, right? That's okay if you can't draw that. Okay, so 12 feet above the hole and 3 feet to the left. So we're going 3 feet to the left. So we're at this point here. And since we're going to the left, I'm going to label that as -3. Okay? So 12 up, 3 to the left. So if I wanted to write that as a coordinate point, how would I write that? Trying to write it as a coordinate point. Yes. Okay, so your left and right go first, up and down second. So it went, we have left 3, up 12. Okay, her first putt traveled 2 feet above the cup, so 2 feet up. Okay, so if you go 2 feet up there, and 1 foot to the right. So this point right here. Okay, so 2 feet above, 1 to the right. How would I label that point? Again, your left and right goes first, up and down is second. Yep. Yes. Okay, so we want to see how far her ball traveled on that first putt. So we want to find this distance right here between those 2 points.
I guess 16.
No. So here's 1 point. Okay, so we have negative 312. And our second point is 1, 2. So I want to label my points just like I did for the midpoint. So we have x sub 1 and y sub 1 and x sub 2 and y sub 2. Okay, and I want to plug those into that distance formula above that I put a box around. Okay, so our distance will be equal to the square root of x sub 2, which is 1, minus x sub 1, negative 3. That quantity is squared. Plus, we have y sub 2 is 2, minus y sub 1 is 12. That quantity is squared. Okay, now I can just simplify. So I have the square root. I have 1 minus a negative 3. So it'd be 4. Okay, 4 squared is what? 16. I have 2 minus 12. Negative 10. Negative 10 squared is 100. It is not negative 100. Okay, when you square a negative, it is positive. Don't forget about that. Okay, now I can add these two numbers together. So I have the square root of 116. You can plug that into your calculator then. So if you have a calculator, take the square root of 116. Okay, that will be about 10.77. Okay, and we were working with feet, so that'll be in feet.
So how come we say feet as in like foot, but we don't say toes?
It's the distance, not having anything to do with the coordinate point itself. What do you mean? Because it's at 12 and then this goes to 2.
That's a good question.
This is negative 3, this goes to 1. It's not going past that. Alright, other questions on example 2? I have one more. Yeah. Yes, that's the answer. Alright, so we're going to look at example 3 then. Okay, so a coordinate grid is placed over a scale drawing of Nita's patio. A grill is located at 2, negative 3. A flower pot is located at negative 6, negative 1. And a picnic table is halfway between the grill and the flower pot. Okay, so in coordinate units, about how far is the grill to the picnic table?
I hope it's pretty far away.
Okay.
You don't want to burn the picnic table. Yes, 6
Okay.
feet.
Okay.
It's a good guesstimation.
So
That's what I'd do.
the grill is at 2, -3. Okay. The flower pot is at -6, -1. Okay. And your picnic table is halfway between those two. So we need to find the distance between those. So, 2 ways of doing this. I think this one might be easier. So, we need the midpoint of these 2 points. So what we did on the front. Okay, so we can find the midpoint of those 2 points. Okay, so to find that midpoint, which is P, you're going to add together your 2 x values, divide by 2, add together your 2 y values, and divide by 2. What? Yeah. It's okay. So I have -2, -2. So that's where the picnic table will be. Okay, so that's your first part. But we want to find the distance. Okay, so we want to find the distance between the grill to the picnic table. Okay, so grill to the picnic table. So we'll need this point and this point. And we can then use the distance formula from the top of the back side here. Okay? So that'll be equal to the square root. Now again, we can label these points. If that's a little bit easier for you, we have x sub 1 and y sub 1, x sub 2, y sub 2. And then we want to plug it into that formula. Okay, so we need x sub 2, that's -2, minus x sub 1, 2, that's squared, plus y sub 2, again is -2, minus -3, and that quantity is squared. Okay, so here I'll have -4. -4 squared is 16. For this one, I have 2 minus a -3, so that's 1. 1 squared is 1. You figured it out? Okay. Okay, so I have the square root of 17. Okay, when I plug that into the calculator, I get 4.1. And we are looking in units. Okay, so for this problem, my first step was to find that midpoint since the picnic table's halfway between the two, and I needed the picnic table to find that distance. Okay, otherwise, a second way you could have done this one was to find the distance between the grill and the flower pot first. So you could have used the distance formula, found that distance, and then divided it by 2, since the picnic table's halfway between. Okay, so those are your 2 different ways. I think this way was a little bit easier to understand. Any questions on midpoint or distance?